everyone, I'm going to go ahead and record a video for number 51 from chapter 6. And this is from the Physics C book. Okay. So on this one, you have, it says, consider a 65 kilogram ice skater being pushed by two others shown below. 1. Find the direction and magnitude of F total, the total force exerted on her by the others. Given the magnitudes F1 and F2 are 26.4 newtons and 28.6 newtons respectively. Okay. So for part A, we have our sketch, and it shows that we've got our ice skater, and we've got one person pushing on her from here, and one person pushing on her from here. So if we just look at those forces, we would see that F1 looks like that, and F2 looks like that. And if we look at those values, F1 is 26.4 newtons, F2 is 18.6 newtons. And it wants to know the direction, the magnitude of F total. Okay, so what we're going to do here is first we can just use the Pythagorean theorem to figure out the magnitude of F total. So on that we can just do 26.4 squared plus 18.6 squared equals about 1,000, and the square root of that is about 32.3. Okay, so that's 32.3 newtons. And then it wants us to figure out the angle of that force. So here we can use tangent. And so we can say that theta is the inverse tangent of opposite. So 18.6 newtons over 26.4 newtons. And so if we run that through our calculator, we would do 18.6 divided by 26.4, and then inverse tangent of that, and we would find that this is 32.3 newtons at 35.2 degrees. Okay, so that's part A. For part B, it says, what is her initial velocity if she's initially stationary and wearing steel-bladed skates that point in the direction of F total? So now we can draw a free body diagram on her, and we can say that F total is going this way. And we know that there's going to be friction going this way. And we need to figure out what her acceleration is. So we know that the force of friction is going to be mu times the normal force. And since she's not moving, it's going to be the coefficient of static friction. Now this we actually have to look up in our book to get the value of, but it does tell us that she's wearing steel-bladed skates. We know since she's ice skating that she is on ice. So if we look up steel on ice, the static coefficient of friction is going to be 0.4. So I'll just write that here. And the normal force, because she has a mass of 65 kilograms, so let's draw another free body diagram looking at her vertically. We know that this is mg, and then that this is the normal force, right? She's not in an incline or anything like that. So she's not moving up or down, so we know that mg equals n, and so we know that 65 kilograms times 9.8 meters per second squared. I'm just going to erase a little bit of this. Equals our normal force. Oops. So 65 times 9.8. So now we know our normal force is 637 newtons. So now we can find the force of friction. And that's going to be this times 0.4. So that is 254.8 newtons. So this is how much friction could potentially hold her in place as she's standing still. We know that the net force acting on her is 32.3 newtons. So that's going to overpower 30 newtons of this, but that's still going to leave plenty of friction to hold her in place. So on this one, her acceleration is actually going to be equal to 0. She is not going to be moving anymore. All right, then our last part of this one, it says if she's already moving in the direction of the net force, or in the direction of the applied force, then what is her acceleration? So on this one, we need, so she's already moving, so our mu is going to be different. So on this one, we're going to use kinetic friction. So that is going to be equal to 0.02 when we are talking about steel on ice. So we can calculate the friction using these two numbers here and the same formula. So now the force of friction is going to be equal to 0.02 times 637 newtons. And that's going to be 12.74. Let me draw a new one of these diagrams. So we know that the applied force total, is 32.3 newtons. Now she's going to have 12.7 newtons of friction. Okay, so now we can figure out the net force of this system by doing 12.7, basically 32.3 minus 12.7, but I'm going to do negative 12.7 plus 32.3 for calculator purposes, and that's going to give me 19.6. Okay, so now we can use that the net force is mass times acceleration. So the acceleration is going to be the net force divided by the mass, which is equal to 19.6 newtons divided by 65 kilograms. So our acceleration is equal to 19.6 divided by 65, which is 0.30 meters per second squared. Okay, so that is how you would solve that one. All right, I hope this helps. Thanks for watching.